All right, today we are going to continue with the next session, especially in PST5, about determination of isotonicity by freezing point method. As you know, it is very important to determine isotonicity before administration of any fluid into the body. This is because of the consequences of administering paratonic fluids. Paratonic fluids, these are fluids which are not isotonic with body fluids. Common consequences may be due to bursting of blood cells or shrinkage of blood cells, which may lead to loss of body fluids, and hemolysis in either case due to bursting or shrinkage. So to avoid that, we need to determine the number of osmoles, or the actual concentration, which is equivalent to the concentration of body fluids, that is to say plasma and blood and tears, so as to administer a solution which shall not bring harm to the human body. So during determination of isotonicity, we have several ways to employ, one of which is determination of isotonicity by a freezing point method. So the whole issue here is to struggle to make an adjusted solution to be adjusted, meaning to make a paratonic fluid to become isotonic with body fluids. So during determination by freezing point, we need to know the concept of freezing point. Hypotonic fluids. Hypotonic fluids have got higher freezing point. If hypotonic fluids have got higher freezing points, that means if we drop or we decrease the freezing point or we deplete a freezing point, automatically we shall be tampering with the tonicity of the fluid. That is to say, if we have a substance to add, an adjusting substance, which will drop the freezing point, then we shall have adjusted the isotonic fluid. Okay, let us make it simple. If we have an adjusted solution, if we add an adjusting substance, then this will be equivalent to isotonic solution or adjusted substance. So this is to say, this can be performed in several ways, as I said, by freezing point method or any other way. But if we have an adjusted substance which is either hypo or hypertonic solution plus any adjusting substance, maybe sodium chloride or boric acid or whatever substance, upon the addition of this, then we shall be bringing this solution to be isotonic. So the questions we are going to solve, we need to have at least two components. One, an adjusted substance, which is a solution which is either hypotonic or hypertonic. Then we need to know the adjusting substance, if it is whether sodium chloride or any other chemical substance. Thereafter, we perform calculations to get the adjusted solution. And so the key concept to understand here is most calculations we shall be performing are about to know the amount of adjusting substance to add in an adjusted solution to make it isotonic. So to know this, before we solve anything about the freezing point, we should know that we have the table of freezing points of common substances and drug chemicals used in pharmacy. These are, as you can see, the list of all used substances. Now, upon knowing that, let's determine the formula for the freezing point. But remember that These adjusting substances, they have been calculated when the concentration is 1%. So this table of figures was calculated when the concentration of these was 1% weight in volume. So the table of figures of freezing points of these substances were determined when it was 1%. For example, for instance, the freezing point of adrenaline acid, it appears on the topmost, it is 0.098, and this was calculated when adrenaline was 1%, when the concentration of adrenaline was 1%. So if it happens that adrenaline is maybe 2%, then you do it by proportion. This is a simple logic that when adrenaline was at 1% concentration, the freezing point was 0.98. What about when it is 2%? Then you get the accurate freezing point. If it is otherwise 3 or 4, then you multiply by 4 and you do the same. So what I want to say here, all figures of freezing point in the table were calculated when the concentration of the figures of the substances was 1%. In case you are solving a question and you find that the concentration is not 1%, then you need to multiply the given concentration by the freezing point, then you get the actual freezing point. Let's consider this example here. There is this common formula during freezing point. W equals to 0.52 minus A over B. So here W, we are finding the amount of adjusting substance. This is the amount of adjusting substance. In fact, we can say this is a concentration of adjusting substance in terms of percentage weight in weight. And 0.52 is a constant freezing point of body fluids. All body fluids do freeze at 0.52 or negative 0.52 temperature. And A is a freezing point of an adjusted substance. Then B is a freezing point of adjusting substance. So if you have the following proportion, then you resubstitute into your formula. 0.52 constant point of body fluids. Then A represents the freezing point of an adjusted substance, which you need to adjust to make it isotonic. Then B represents the freezing point of adjusting substance. Now, there is a special concern on A. As I said, A was calculated when the concentration was 1% weight in volume. So the freezing point of A was calculated when the concentration was 1. If the concentration of A is not 1%, then you have to multiply that concentration by the freezing point to get the actual A. Okay, let us proceed. We are going to understand soon and very soon. All right, example number 1. We need to adjust 1,000 meals. So needed, we need to adjust, meaning we need to make this solution isotonic. We need to adjust 1,000 mils of 2% dextrose to will be isotonic with body fluids. The adjusting substance is sodium chloride. All right, so let's think on this. We need to adjust 1,000 ml of 2% dextrose solution. So an adjusted substance here is A. So dextrose is A. This is an adjusted substance which we need to adjust. And an adjusting substance, the substance we are going to use to adjust the concentration of dextrose is sodium chloride. So adjusting substance, sodium chloride is B. Remember, we said that the concentration of dextrose or the concentration of an adjusted substance should be 1. And this is 2, which is not 1 or not equivalent to 1. What should we do? In order to get A, we should take 2, which is the concentration, times the freezing point of dextrose. That's when we shall get A to substitute here. So plugging into our formula, 0.52 constant freezing point of body fluid minus A, this is 2% because it was not 1, times the freezing point of dextrose. So the freezing point of dextrose, when you check in the table, this is 0.101. This is 0.101. So this figure is obtained from the table which was displayed before. Then the rate of adjusting substance, the freezing point of adjusting substance is 0.576. When you check in the table, the adjusting substance, which is sodium chloride, its freezing point is 0.576. So when you calculate, you get the following figure. You get 0.552 percentage weight in volume. This is W. So up to this moment, remember W in this formula, W should come out as percentage weight in volume. So we were looking on the amount of adjusting substance, and now we have the concentration of adjusting substance, which is sodium chloride. Sodium chloride 0.55, this is not the amount, this is the concentration. So to get the amount, consider this concentration, 0.552 means 0.552 grams are in 100 ml. So what about the total solution, which is 1,000 ml? This requires how much? If you try to multiply, you get 5.52 grams of sodium chloride. So practically what you shall do is this: obtain 5.52 grams of sodium chloride, or weigh 5.52 grams of sodium chloride. After weighing, take it and mix it with 1,000 ml of 2% dextrose, which was on the table. Then stir well the preparation to obtain a clear solution. After that, your preparation shall be well adjusted, or it shall be isotonic already. Let's consider the next example before we finish this session. We will have to render the following solution iso-osmotic with blood and tears. This is a solution of ephedrine hydrochloride and chlorbutyl in water. So this is a solution. We have ephedrine. This is 0.1 gram. Then we have chlorbutyl, which is 0.1 gram. Then we have water for preparations, which should be added up to 20 ml. The adjusting substance is sodium chloride. So this solution here is not isotonic. It's not isotonic with body fluids. That is to say, it is not adjusted, it is unadjusted. We need to adjust it by using an adjusting substance, which is sodium chloride, to make it isotonic, to make it adjusted. So what do we need to do is to use our formula, W equals to 0.52 minus A over B. So what is A? A means an adjusted substance. So the ingredients which are not adjusted in this solution are ephedrine and chlorbutyl. So we have got two A's, which means we're going to determine each and sum them. So our first A is ephedrine, the second, this is ephedrine, the second A, this is chlorbutyl. At the end of the day, we are going to sum them to get A total, then we substitute here. All right, so remember when we are dealing with W here, it should come out as a percentage weight in volume. That is to say, these amounts should be in percent when using this formula. So we need to change the concentrations into, the quantities into percentage strength. So beginning with the ephedrine, this is 0.1 was dissolved in 20 ml. Then how much is in 100%? When it comes to chlorbutyl, 0.1 was in 20 ml. How much is in 100%? This is 0.5%. Okay, now let us proceed. Okay, after obtaining the concentrations in terms of percentage strength, remember this percent is not equivalent to 1. As I said before, in order to calculate this, you need to understand that the freezing point depressions were calculated when the concentration of an adjusted substance, so drug chemicals, were at 1%. Considering this is not 1%, then it should be multiplied by its freezing point to get the actual freezing point. So the freezing point depression of ephedrine, when you check in the table displayed before, is 0.165, and the freezing point depression of chlorbutyl is 0.14. Therefore, when you multiply, you get 0.5 times 0.165. This is 0.0825, and this is 0.14 times 0.5. You get 0.07. So because all of these are A, they are not adjusted, you need to sum them up and get a single A. And this is 0.1525. So 0.1525 is our A. That means that is a freezing point depression of an adjusted substance. So write this figure here, 0.1525. Then B, this is the freezing point of adjusting substance. The adjusting substance was sodium chloride. So sodium chloride, when we check in the table of freezing point depression, this is 0.576. Here you'll get W is equivalent to 0.638 percentage weight in volume. So to get the actual amount of sodium chloride to use, consider its concentration as W, 0.638 grams in 100 mils. So the total solution at 20 mils. So what is the required amount here? The required amount is 0.013 grams. Practically, after doing this, scoop 0.013 grams or weigh 0.013 grams of sodium chloride, then mix them within this solution. Thereafter, mix it well, it will be already isotonic. Or the other way around, weigh 0.013 grams of sodium chloride, then weigh ephedrine 0.1 gram, weigh croptol 0.01 gram, then dissolve them in a proportion of 20 mils of water. Then that is all about using the freezing point depression. During our conclusion, do not forget, W means the amount in the concentration of an adjusting substance. A means the freezing point depression of an adjusted substance. B means the freezing point of adjusting substance. And remember, when calculating W in this formula, the figures here should be in terms of percentage strength. If not, change them, then perform the calculations as usual. If you have more than one active ingredients, then you have more than one A. Then find each A individually, thereafter sum them as we did here, then finish up your calculation. Thank you. Now let's go into the next session.